In this video, we're going to look at solving inequalities and graphing solutions. So all of this information is in your media lesson packet. I'm just going to highlight a few important things. When we solve inequalities, we will use the same process that we use to solve equations, except that if we multiply or divide by a negative number, we will reverse the direction of the inequality sign. And we saw that result when we used the construction webs, and we saw our properties of inequality were different when we multiplied or divided by negative numbers. Okay. We will also need or also learn to graph the solution set of an inequality. So when we solved equations, we might have a solution like x equals 3. Now we'll have something like x is less than 3. So we're going to have an infinite amount of numbers that make the inequality true, and we want to represent those on the number line. Okay. Now here's some information. I'm going to refer to this in context in the graphs on the next page, but you should use this for a reference. When you forget exactly, you're thinking, do I use an open circle or a closed circle? Do I use a parenthesis or a bracket? This summarizes that information. So let's look at the graphs, and then we'll see the patterns and how we set things up. Okay. So here's the idea. So notice here we say solution set. This is inequality notation. This is the solution set graphed, and this is the solution set in what we call interval notation. So when you solve an inequality algebraically, this is the type of result you're going to get. Just like you would get x equals 3, now you'll have x is less than 3, or x is less than or equal to 3, etc. Okay. So now there's two more ways we want to represent this solution set. So here we have inequality notation. Now here is how we'll represent the graph. So notice this is x is strictly less than 3. Okay. So you're going to look at your boundary value, which is the number 3, and notice this is 3. Since 3 is not in the solution set because there's no line underneath it, we use an open circle, which means omit the number 3. Okay. But any value less than 3 is a solution, so we draw a line to the left and we use the arrow to indicate that we go on forever in the negative direction. Now in terms of interval notation, you always write the smaller value first, or the value furthest to the left. That's a better way to phrase it. So we're going to put furthest left, comma, furthest right. Okay. And I'm putting parentheses here. They could be parentheses. You'll notice sometimes we use brackets, and we'll see why in just a minute. So first we say what's the furthest the solution can be to the left in the negative direction. And since there's an arrow, there is no furthest to the left value, so we use negative infinity. The furthest value to the right, the boundary value, is 3. So on the right-hand side, we put 3. Now you need to make a decision about whether you're going to use parentheses or brackets. So comparing these two, notice the only difference between the first row and the second row is that the second row includes the possibility of it equaling 3. Okay. So notice the only way these differ, both of them have negative infinity on the left-hand side with a parenthesis. Okay. But here we have 3 in a parenthesis, and here we have 3 in a bracket. Notice that's a square bracket. That's what we usually say. It's sharp instead of smooth. Okay. So for negative infinity or infinity, we always use a parenthesis. Okay. And if we can include the value, such as here, less than or equal to, we fill in that circle on the graph, and in the interval notation, we use a bracket. If you cannot include a specific value, it's an open circle, so you draw a circle, but you don't fill it in, and you use a parenthesis. Okay. Let's look at these two. So it's a similar idea, but now x is greater than negative 7, or x is greater than or equal to negative 7. So the boundary value is negative 7. Notice these are both plotted. Okay. Here the circle is filled in. Here it's not, okay, because we can include negative 7. And we want all the values here greater than negative 7. So that's to the right. and the same here. Notice the only difference is this circle is filled in. Now looking at the interval notation, remember we start with the furthest to the left, then the furthest to the right, always. Okay. So the furthest value to the left here in both of these is -7. Notice the only difference, here we don't include -7, so it's a parenthesis. Here we do include -7, so it's a bracket. In both cases they go on forever in the right-hand direction, so we have parentheses. And notice here we write just infinity, that means positive infinity. To the right is the positive direction. Whereas here it was the negative direction, so we wrote negative infinity. So that's how we distinguish between which direction. Left direction, negative infinity. Right direction, positive infinity. And finally this one, okay, we call this a double inequality. The value of x is bounded between two values. X is between -3 and 2. So our left-hand boundary, instead of being negative infinity, is -3. Notice there's a circle because x cannot equal -3. It's strictly less than, or -3 is strictly less than x. Okay. And then x is less than or equal to 2. So on the right-hand side we go up to 2 and we include 2. So these are all the values that are in our solution set. Notice the left-hand side is the value furthest to the left, which is -3. We have a parenthesis. The value furthest to the right is 2, and we have a bracket because we're including 2. Okay. So also notice here we have a circle because it can equal -3, and here we have a filled-in circle because it can equal 2. Okay. So that's going to be our general strategy. Now let's solve a problem and graph the solution. We're going to do a few of these, but let's just start with one. Solve the inequalities, then graph their solution sets and write the solution set in interval notation. So here's our inequality. Okay. So let's look at the construct process, the deconstruct process, and then we'll solve this using the properties of inequalities. Okay. So now remember, we said on the previous slide or 2 slides back that our one difference between solving equations is if we multiply or divide by a negative, we reverse the sign of the inequality. We're going to see one more issue we need to be a little bit careful with, but let's just solve this and I'll bring it up as we go. So first, we'll write our construct process. So we have x is decreased by 4. And the result is greater than 3. So that's a pretty short construct process. Okay. So here we have decreased by 4, and the result is greater than 3. So now that was our construction process. Now we want to deconstruct that process. Okay. So we have 3 was our result. So 3, instead of decreasing by 4, we want to increase by 4. So 3 is increased by 4. And now here's the part we have to be careful of. We're going to start with x. The result, x, is greater than, I'm sorry, I shouldn't say it that way. X is greater than the result. Okay, so you may not notice that this is a little bit different than how we dealt with equations. Here in the equations we might have said the result is equal to x or x is equal to the result, and it didn't matter. Here it matters because remember, inequalities are not symmetric. So if we change the direction that the x is on, we could make an error. So here's what we're going to do, and we're going to verify this using the principles of inequality, is when you write your last line, always start with x. Okay. Use the sign that you started with, in this case greater than, or if you had divided or multiplied by a negative, we're going to make a notation to reverse that direction and then put the result. Okay. So here we have, we'll write this as 3 is increased by 4. Now I have x is greater than the result, so I'm not going to put this on the right. I'm going to put x is greater than the result. Now we can compute 3 plus 4 is 7, so x is greater than 7. Okay. Now let's look at this using the principles of inequality. And again, it's a lot simpler, it's less steps, but this process helps you understand how the inequality was constructed, deconstructed, and basically its structure. Okay, so this still has value. Here, we know that we have x minus 4. Okay, we want x by itself. We know we can add any quantity to both sides of the inequality, and the inequality is still true. So here, adding 4 to both sides, we have x is greater than 7. And notice that corresponds to our result here. Okay, so that also validates what we have done here, that x is greater than the result. So you're going to write your result on the right hand side, your x on the left, and you're going to use either the original inequality symbol, in this case greater than, or you'll change it and invert it based on any operations, multiplication or division that you did with a negative number. Okay. Now let's graph this. So to graph this, I'm going to start with the boundary value. So the boundary value is the number 7. Okay. So since it doesn't have an equal sign on the bottom, I'm going to go to 7 and draw an open circle. 1, 2, 3, 4, 5, 6, 7. Here's 7. Open circle. Now what we need to know is, are we going to draw an arrow to the right or to the left? Okay. And notice it says x is greater than 7. And you may realize that that means the numbers greater than 7 are to the right. Okay? But if you're not sure, you can always pick a test value. Okay? Until you start being able to read this and you just know which direction it is because you practiced enough. So if I picked a test value of 0, 0 is not greater than or equal to 7. It's less than 7. So for me, that means I don't need this side. This side isn't true, it's the other side. So I'm going to draw an arrow this way. Okay, I'm actually going to get a highlighter to do this because it's hard to see. Open circle and then arrow to the right. Okay, so you don't have to make this super thick on your number lines, but sometimes if you're using a pencil or a black pen, you won't even be able to see the inequality. So I just wanted to make sure you can see it. Note this is an open circle. Okay. Now let's write our interval notation. So remember, interval notation always start with the leftmost value. In this case, the leftmost value is 7. It's an open circle, so I'm going to use a parenthesis, 7, comma. The rightmost value, I'll notice it's going to the right with the arrow, which means to infinity. So I'm going to put an infinity symbol. Infinity symbols always have parenthesis, and there's our interval notation. So in the next video, we're going to practice a few more of these now that we've gotten our base ideas set up.